You are given a sorted array called nums, and your task is to remove duplicate values in place, meaning you cannot use additional space to store a new array. The goal is to ensure that each unique value appears only once in the array. After removing duplicates, the unique elements should occupy the first k positions of the array, where k is the count of unique elements. You must return the value of k representing the number of unique elements in the array. Additionally, the relative order of the unique elements in the array should remain the same as their original positions. Okay, so we need to make everything the same. We cannot remove we cannot use additional space to store a new array at all. So how we can do that? Like, since the array is sorted in non-decreasing order, all duplicate values will appear will appear next to each other. Like what was the word for it? Like, it was consecutively. I guess it's something like that, but my pronunciation is pretty bad. So the thing that, if since this array is sorted one, you will see that all the values that equal each other, they will be like neighbors. They will always be neighbors. They will be next to each other. So we can take this in our advantage and try to make a solution based on this point. Like, this allows us to use like a two-pointer technique to solve the problem efficiently. Like, we can use a pointer we called k to track the position where the next unique element should be in place, and we use another pointer, which is I, for example, to iterate through the array and compare each element with the previous one. Whenever a new unique element is found, nums of I, for example, or nums of I minus 1, we copy it to the position indicated by k and increment k. For example, by the end of the traversal, the first k elements in the array will contain all unique values, and k will represent the number of unique elements. How we can do that? Okay, it's pretty simple one. First, I want to make a pretty simple case here, because the length could be less than or equals to 1. So if num the length equals 0, if that was the case, we return 0. Other one, we use our pointer, let k equals 1 for we will make our for loop. For this one is our pointer. It's indexed for the next element. It's always should be like that. We start let I equals 1, because we all the time try to compare the previous. Let I equals 1, I less than nums the length, I plus plus, and I guess there's no need for this one. I guess we can continue in like by one of the if statements. We create one if statement if nums of I doesn't equal nums of nums, not nummy, nums of I minus 1. If they don't equal each other, that means they are not, like, there is no duplication. So nums of k will equals nums of I and k plus plus. Okay, and after that we return k. It's pretty simple problem. It's really a simple one. Let's run and see. Let's submit and see. Okay, it's okay. We're killing it. We are killing it. So, okay. Here we use a pointer we called k, and to track the position where the current unique element should be placed. After that, we use another pointer called I, and this one to iterate through the array and compare each element with the previous one. After that, whenever a new element or a new unique element is found, like nums of I is different from nums of I minus 1, if that was the case, we copy it to the position indicated by k and increment k. By the end of the traversal, the first k elements of the array will contain all unique values. And I guess the trick of this problem is the requirements, because it tells you just to return k, so we don't have to make any swap, we don't have to make any change of elements, we don't have to do anything like this at all. What we have to do, what we truly have to do, is to scan the element and scan the array and return k. That's it. So if we take this, like if they take the first one here as an example, we start with k, which equals let's take this an example. Let's copy this one. So when we copy it, I guess it will be easier for you guys to understand the problem. So let's start with this one, an example, and we start k to equals 1. And we compare nums of 1 with nums of 0, because we start I will equals 1 as well. So we say here, they equal each other. So nums of 1 and nums of 0 both are equal to each other. So we skip, we don't do anything, and we continue looping. We have here I will equals 2, and we compare I of index 2 and with its previous. They don't equal each other at all. So we have here k will be plus plus, so k will be 2, k plus 1, it will equals 2. And basically it means the first two elements, or like we should return the first two elements, or we have two elements that are unique, and this is how it works. So yeah, it's a pretty simple one. It's a pretty simple problem to be solved. The only trick is to understand to take the sorted array in your advantage and use a pointer. And I would say most of the problems in LeetCode, you find like using you could use a pointer, a map, or like a backtracking mechanisms. You find most of the problems will be solved on one of these three things. Not all of them, but you find a lot of them will be solved with one of these three things. So yeah, that's it for this video, and see you in the future.